Bismillahirrahmanirrahim. Dear viewers, today we will design steel structure in Cype 2022. We will design structural members in Cype 3D, and also we will design general connections in between structural members in Cype 3D. Complex connection we will design in Cype Connect Steel or StruBIM Steel, that is additional app with Cype. So let's start. Open the program Cype 2022. This is complete BIM software. In the structure tab we will get the structural analysis and design modules. From here we will go to Cype 3D. We will create new file. Accept. We will start with empty project. Accept. Here we can choose our codes: American code, Euro code, IS code, Indian code. Lots of codes are available here. I will continue with American code. So concrete, same as it is. Rolled steel, I will choose AISC LRFD 36005. Foundation, same as it is. Here we will not use timber or aluminium. Accept. Uses categories of the structure we will choose as general. Rolled steel, I will choose A572 50 KSI. 50 KSI. Foundation element, that with F'(C) 300. We will add additional load case, dead load. Accept. Accept. Live load, add. Accept. Accept. Here we can define wind load case, earthquake load case. In this structure I will assign only vertical or gravity loads, because this structure is only two-storied structure. Accept this one. Finish. Accept. From here we can create new bar, or from here also new. Here we will choose the section. Type of element generic. This tie means this will be selected if we need to assign bracing. We will start with generic. Here available section ASP, ASW, these are standard rolled section. We can import more standard section from here. Here you can see IPE, IPB, IPN, AISC section, ASW, ASPM, Indian standard, JB, LB, MB, SC, WB, SB. Okay, we can import this IPE section. Accept. Accept. And also we can create built up section, that means customized section from here. Reference section series, we can type here for steel columns, add SC 200 by 10, 175 by 10, like this, 200 millimeter depth, flange width 175, thickness 10 milli. Here if there is slope of flange, we can select this. Chord radius between flange and web, like this. Okay, other options are available here. We will continue with simple built up section. Accept. Plus SC 250. Accept this one. More we can add section series name main beam MB. Add accept. We can copy this one, then we can edit. Accept. Accept this one, then accept. First we will start with steel column section. Accept. From this point our floor height is 3.8 meter, plus we will create column splice joint or connection 80 centimeter above the floor level. So 3.8 plus 80 centi, it will be 4.6. Click here, 4.6, press enter. Click 4.8 meter, this side 3.6 meter, like this. For columns we will choose steel column series. For beams we can change the section. Describe these beams. We will change to main beam section series. Accept. Now we can copy the elements. Accept. Select the elements. Right click. Reference node. Like this. Again we can copy. Right click. Now model. From here to here. Click 1.2 meter. From here to here 1.2 meter, like this. Now we will model sub beams. New, we will choose standard section here, IPE, for example 120. When we will do analysis and design, we will choose optimize design, then it will check the design with all the sections, and from there it will show the optimized section. Accept. Click on the main bar, it will show the distance. We will take distance 1.2 meter from here to here, 1.2, like this. 1.2, enter here. Now we will assign pinions for sub beams. Pinions, if we click on left side, it will assign pinions at left side. If we click on right side, it will assign pinions at right side. If we click on middle, it will assign pinions at both side. Click on this, click on this, click on this. Okay, now we will copy elements. Accept. Right click, like this. Here we can model manually from here to here, from here to here. from here to here. We can see 3D view. Now we can assign bar position. These bars are at middle position. We will assign bar position as top for the floor level. So go to bar, describe this position. Now select the bars or beams, right click. Now it is in mid position. We will assign it at top position, accept. And as I have discussed before, our column splice joint will be 80 centimeter above the floor level. So we will copy this elements, right click, then select the node and downside click 0.8, enter. And this other bars we will delete at this level. We can delete extra nodes also, like this. Now we can assign support condition. Go to node, external fixity, select the nodes, right click. Here define types of fixity we will get. If we want to customize, we can choose this one. Then we can customize the support type. Here we can assign elastic properties for the support, subgrade modulus K. Here we will choose fixed support, accept. Now we will assign load, introduce load on panel, right click, accept. Load distribution direction this side, right click, then assign load self weight. Here we can model concrete slab for getting the slab self weight, but to reduce the analysis time we can apply self weight on panel. For decking slab, if we choose 100 millimeter concrete slab thickness, then the slab self weight is coming 0.1 meter into slab unit weight or concrete unit weight 23.5 kilonewton per meter cube. So multiplying by 0.1, it will come 2.35 kilonewton per meter square. Accept this one. Another, right click, then load distribution direction this side, accept. Accept. We can see the resultant load values, visible load case for dead load, accept. So loads have been distributed to beams according to the load distribution direction. We will copy the elements with panels, accept. Select the element, right click, from here to here. As it is two-storied steel structure, so we will delete the extra portion of columns. Delete. Using this one we can delete, or if we want to delete member with node, then we can choose this option, delete nodes. Select the nodes, right click, like this. Now here our floor height coming 0.8 meter plus 3.8 here. So we will move the members 80 centimeter down to keep 3.8 meter height for this floor also. So click on this move option, accept, select, right click, then reference node to downside 0.8, enter. We can apply wall load also. Load, introduce loads on bar, load case dead load. We will select bars to assign wall load. Right click, uniformly distributed load, this one. Other loading options also available. 8 kilonewton per meter loading for this floor. Parapet wall load. Right click, 3 kilonewton per meter. We can see our structure 3D view. So now we can go for analysis and design. Go to analyze. If we choose this one, it will not optimize the design. Quick section design, using all the sections of the series. We will choose this one, accept this one, accept. Here it is showing that we have not assigned buckling coefficients, moment coefficient, lateral buckling, other things. If we need to assign these coefficients, we can assign. I will show later. Now here we can see all the members passed. If we choose the section, it will show the resistance 37.80%. If we choose this section, 10.63%. Above 100%, the member will fail. Below 100%, the member is passed. Okay. From here, we can assign buckling coefficient by clicking on this. Right click. We can choose the buckling coefficient. We can assign lateral buckling to our beams, top flange, bottom flange, all the option. Now we can assign joints or connection, generate. Yes. Here connection nodes generated. We can go for joint design. Here node with welded connection, node with bolted connection. We can choose this. Here are some warning for member web flange thickness incompatibility with connection. See the red joint. So if we change some member, this can be solved. For example, this middle one, I can choose this and this. Right click. I can choose this one, larger section. We can make grouping also. Go to bar, group. Group. In this way, we can create grouping. Now we can go for analysis. In this time, we will choose do not dimension section. That means what we have provided, we want to keep same section. Just we need to check the design. Joint design. Joint edit. We can edit joint from here. SB to check the internal fixity. Here we forgot to assign pin end, so go to bar pin end, this one, this one, this one, this one. Okay, now go to analyze, accept, then joints. So almost all the joints have been passed except few, and here this position joint has not been created because of this complex arrangement. This one we will model in StruBIM app. We can explore analysis result also. Go to analysis. We can see displacement. Here you can see the displacement by clicking on the members like this. We can see reaction value by clicking on the node at foundation level like this. RZ 235.48 kilonewton. Here this one 101.4 kilonewton. Here 313.52 kilonewton. Like this we can check forces, load combination, for this one axial load, display maximum and minimum value, shear VZ, torsional moment MY, MZ, deformed shape. Here you can see the deformed shape, deflection, XY, deflection XZ, like this. Close this one. We can generate drawing also. Drawings, add, accept, another 3D, accept this, drawings generated, detail of all drawing. Okay, we can export to DWG format, accept, close this one. We can see the drawing. Here is the 3D structure with the joint or connection type. From this 3D structure with connection type marking, we can find out which type of connection details have been done in this sheets. This one, for example, type 1. Here we can delete the hatches. Type 1. Here this one, type 2, type 4. For type 1, we can see here these two type 1 connection joints also have been grouped into different types. This type 1 here, type 1, this is base plate connection. Here this one type 2, that is column splice connection. So everything is very precise in the drawing. So in this way we can do design of steel structure with connection, and we can generate drawing. For critical connection we can design that one in StruBIM steel or Cype connect steel. So now first we need to export this model to BIM server. Project selection, create new project. Accept. Now we have to export this model. Accept. Export finished. Then we will open StruBIM or StruBIM steel. Go to new tutorial by decode BD. Accept. Select project. This one here in the list we will get that project tutorial. Accept. Then next, here the model, click on this import from Cype 3D. Finish. This section we have customized as built up section. This section will not be available in library. We will import this section. Accept. A5 7250 KSI. Accept. This joint. From here go to joint, new. Now select the members of the joint, then right click. Now here we have to create the customized joint. First we will create reference plan perpendicular to the section here, this one V2. Okay, now displacement this side 100 mm, so we need to take it -50, like this. Now we can create plate here. V2 web, like this. Then we can adjust section B2 with plate, like this. Weld. Okay, now we can increase to 20, width to 20, like this. Thickness we can take 12 milli. Now another plate we will create. This side will be back face of the reference plan, and adjustment, another v1 to the plate 2, like this. Here we can see this sub beam also connected here, so we need to choose the plane. We need to move the plane more this side, left side 15 millimeter, so that we can avoid this collision with sub beam. Now we can provide bolts to these plates to connect these two members. Bolts, element plate 2. Here add bolt, okay. So we have added bolt. We can make it reverse direction like this. Now we can assign connection to this sub beam plate, material S355. Other plate also we need to choose the material, bolt we have to choose here, material 4.8, thickness 12 mm, like this. So we have assigned our connection elements. Now we will go for analysis. Here run the analysis. Top flange front weld adjustment 1. Here problem with adjustment 1 welding. So go to model, adjustment 1. Here problem with our flange not getting full plate. So here we need to increase the plate width. Now we can check again. Now it is running the analysis. So here we can see the analysis result. This bolt has been failed, so we can change the arrangement. Go to analysis. Okay, now this bolt is passing. It is below 100%. We can see the stress also. Von Mises stress. Like this. We can see equivalent von Mises deformation. We can increase the scale 5, enter, like this. Displacement, like this. Okay, so in this way we can do analysis and design of customized connection in StruBIM steel or Cype connect steel. Okay, we can get the result. Except here, this one we can export to PDF format or directly print. Here we can see the check. This one also you can export to the PDF. Except now here this connection added to the structure. In this way we can add several complex or customized connection to the structure as per our requirement. So in this way we can design customized connection in StruBIM steel and other general connection we have designed in Cype 3D. Here we can see the column splice joint also. We can click on edit. Here the splice has been done in this way. We can change it connection using cover plate. Design, accept. Here the check result or calculation. Okay, like this. Accept, done. Other this one also we can change it to this one. Design, accept. Okay, like this. Accept, We can see in 3D view, go to tools. Here we can see the connections. So in this way we can do general connection design in Cype 3D and customized connection in StruBIM still or Cype Connect still. Okay, so thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.